Hi there, welcome to Camping Secrets. I'm Marky Mark. Now, recently I've been reviewing quite a few of these battery power stations. You know the thing, I've got one here, I've got the Jackery Explorer 1000 and I've got the Bluetti EB70. So these are power stations where you can put power in from your mains or from a DC 12 volt or even from solar power. And they will store power until you need it. Then when you're camping or if you've got a power cut at home, you can use these power stations to drive equipment up to the rated power of the inverter. Some of them use different battery technology and I want to explore that. On the one hand, you've got Jackery. I love their Explorer 1000. It gives 1000 watts of continuous power and it's got storage of 1002 watt hours. Now the Jackery uses standard lithium-ion battery technology. So that means it's got a graphite cathode. And what does that mean? We're going to go into that. And I'm going to directly compare the Explorer 1000 with their main competitor. The Bluetti EB70 is one of my favourite power packs. Now this has also got 1000 watt output. So we can directly compare these two power stations driving the same device. You've got less storage here. How does it compare? Because this uses different battery technology. It uses lithium-ion phosphate technology in the batteries for the cathode. We're going to look at these directly together today and see how they pan out. Jackery, Bluetti, standard lithium-ion, lithium-ion phosphate. Let's dig into this. So let's have a chat about the battery technology. As I say, Jackery use standard lithium-ion battery technology. They don't say specifically what cathode they use in the battery, so I'm assuming it's a graphite cathode. It could be nickel manganese cobalt. Now the thing is with nickel manganese cobalt, you've got to mine it out of the ground. It's quite difficult to get cobalt sometimes. So in terms of environment, standard lithium is a little bit of a nightmare and it could be a concern going forward in terms of the environment. On the other hand, the lithium-ion phosphate cathode used in the Bluetti batteries doesn't contain the cobalt, so it's much easier to mine the materials needed for the lithium-ion phosphate. So that's one advantage to lithium-ion phosphate. Secondly is energy density. Standard lithium-ion can contain more energy in the same size battery than lithium-ion phosphate. And I want to check that. So we're going to measure the dimensions, we're going to weigh both power packs, and then we're going to compare the storage of each for the size and weight of each power station. I'm expecting Jackery to win that due to what I've read. I haven't actually measured it, all the dimensions and compared them directly. Lithium-ion phosphate has slightly less energy density, as I say, but is it enough to make a big difference in terms of your choice for a power pack? One area where lithium-ion phosphate is far superior is in the number of charge and discharge cycles that you can use on these power stations. For instance, with the standard lithium-ion battery technology, Jackery say that the Explorer 1000 can do around 500 charge-discharge cycles before the battery capacity is dropped to 80% of its original starting capacity. In contrast, the lithium-ion phosphate cathode in the Bluetti batteries, Bluetti say this can do 2,500 charge-discharge cycles before the battery has reached 80%. So basically, the lithium-ion phosphate batteries can last 5 times as long as the standard lithium-ion. If you think about that, that massively increases the lifespan of your power station if it can do 5 times as many charge-discharge cycles. You know, so if this, say, you're down to 80% after 2 or 3 years, this will still be, 100% at that point, most likely, or, 95 or something like that. So that is a big win there for the lithium-ion phosphate. One other area is safety. I know these aren't electric cars or Teslas or whatever. It's unlikely you're going to have a massive fire. They've got electronics inside to really control the batteries and look after them. So I don't envisage any problems with either of these. But the science does say that there's a much reduced chance of fire and explosion with the lithium-ion phosphate. So, overall on paper, lithium-ion phosphate does look the better technology, but the energy density question is really important. Which one stores the most in the biggest size, and is that important? Right, so let's get down to dimensions. I've got a tape measure here. I'm just going to write down the Jackery's dimensions. So, if we measure that, it's 32 centimeters by 23 by, ignoring the legs, by about 21. And then the Bluetti, now of course that's 32 again by, of course there's other things in here, there's an inverter, there's electronics, but I would say the most of the size of these power stations is dictated by the batteries themselves. So that's 32 by 20, and then the height, 22. So the Jackery is 15,500 centimeters cubed, and the Bluetti is 14,080 centimeters cubed. So slightly bigger volume for the Jackery, but, and it's a big but, on paper it stores more power. So the storage of the Jackery 1000 is 1,002 watt hours, and the EB70 Bluetti is 716 watt hours. In a minute, but on paper you can clearly see that the Jackery has better energy density, 0.065 watt hours per centimeter cubed, and the Bluetti 0.05 watt hours per centimeter cubed. So it's looking at, this is around 20% more energy per unit volume. Okay, so let's get the Jackery on the scales. Ooh, 10 kilograms exactly. Let's do that again. Get the Bluetti on the scales. That's 9.7 kilograms. Okay. Yeah, so it's a similar comparison in terms of, and it depends what's important to you. Is the size of the unit important, as in the volume, the space it takes up for the amount of storage it's got, or is it the weight? I mean, these both weigh about the same. The Jackery is slightly bigger, but it has way more capacity than the Bluetti. So, this is gonna, I hope, when we do the test, this is gonna last longer, much longer when driving a device than this one, and yet they're about the same size and weight. So let's get these devices fully topped up and then run them till they run out of power, and we'll see which one lasts the longest. Okay, so we're going to start with the Jackery Explorer 1000. 1,002 watt hours of battery on board with standard lithium-ion technology. It's much more energy dense on paper, so it should last longer than the Bluetti. Now, I've got a fan heater here. It's about 1,000 watts, so it's about at the maximum power that both of these power packs can drive. And it's really cool that it can drive these. I mean, if you go camping and you want to use this, you can blast a bit of heat, really good. So I've bought myself a power meter, and this means I can independently verify how much power the fan heater is drawing out of the Jackery. The Jackery has got a display, and we can compare the two and see how accurate the calibration of the Jackery display is. And then we're just going to start a stopwatch, and we're going to run this until it goes from 100%, it's fully topped up at the moment, down to 0, and we're going to film the whole thing. Okay, so let me get my stopwatch ready. Here we go, stopwatch. So let's plug in the fan heater. and turn on the AC. 100%. And we're off. So the Jackery's saying it's drawing about 910 to 925 watts. And my power meter is saying 883. So, and that is rock steady. So the actual power is not varying very much, 883. But the Jackery is sort of all over the shop, and it's actually around 910 to 920. So there is a bit of a calibration error there. The Jackery is saying it's supplying a bit more power than it actually is, and I totally trust this power meter because I've calibrated it myself against other equipment. So we got the Jackery going here and filming it, and the fan heater is going. So while that's going, it's worth just trying to work out on paper how long we think this would last. So look, we've got 1002 watt hours on paper, but that doesn't mean all that storage can be used for the fan heater. The Jackery itself uses a bit of power, and there's also efficiency of the inverter and the battery transfer of electricity from the Jackery to the fan heater. So all those 1002 watt hours are not all going to be usable, and typically on paper you assume maybe a 90% efficiency. If we take 90% of 1002, it's about 900, and the fan heater is using about 900 watts. So on paper I'd probably expect it to last 1 hour going at this power. So it'll be really interesting to see if that's the case. Let's have a look how we're doing. Bit of time lapse now, and let's roll that clock forward and see how we do. Okay, we're sort of part way through the Jackery now, and let's see what's going on. So we've been running for nearly 43 minutes. It's still pumping out around 888 watts from the fan heater here, and we've still got 33% of the battery left. So it's doing well, the old Jackery. I think it might get to the hour at least. Let's come back in a few minutes. Okay, we're getting close to the end now. 5%. And power is starting to come down. It was 888 for a long, long time. As we're getting down to 3%. Yeah, even the Jackery now is dropping to under 900. Power is going down. And the last 2% is not able to supply that 880. Down to 868. 2% left. We've had 59 minutes. Can we get to an hour before we've still got heat coming out of the fan? 2% left. Power's dropping. 860. Be lovely to get to the hour. 59 minutes 20 seconds. I actually started the stopwatch a little bit late, so I am going to call this an hour. I was about 30 seconds before I started the stopwatch stupidly. 2% still. Power now down to 850. This is still impressive. Still going. 1% left. Power down to 845. I think we're going to get the hour on the clock, so that's about an hour and 30 seconds. Yes, we got the hour. So basically I think this has performed exactly to spec, assuming a roughly 90% efficiency, but we'll work it out in a minute. 845 watts. It was only in the last couple of percent that that power dropped. It's still good, and we're gone. Okay, let's get the camera out. Well, that was exciting. So, we've got 1 minute and 30 seconds on the stopwatch here. I was around 30 seconds too late to start the stopwatch, so I'm going to call that 1 hour and 1 minute for the Jackery. And it was pumping out 887, 888 watts for that full 61 minutes. So we're going to say the average power was 885 watts, I would say, because it dropped a little bit at the end. So just taking into account that, that's about right for 61 minutes. So if we divide 61 by 60, divided by 60, and then times that by the average power that we were drawing, which was about 885, that's 900 watt hours of real energy. Okay, so that's quite interesting. So the specification of the Jackery Explorer 1000 is that it's got 1002 watt hours of storage. But what we've shown here is when you're driving something in the real world, there's an efficiency. The Jackery's got to power its fans, it's got to power the display, it's got to power the battery management. There's an efficiency loss of the inverter. So although it's got 1002 watt hours on paper, it can't deliver 1000 watts for an hour. So we've shown here that the usable storage of the Jackery is 900 watt hours versus 1002. So it is about 90% efficient in terms of storage. So it's worth bearing that in mind when you buy a power pack. You're not going to get the headline number. It's about 90% for the Jackery. Let's do the same experiment now with the Bluetti and its lithium-ion phosphate cathode. This is 716 watt hours on paper. So let's do the same 90%. 0.9 times 716, 644. So I'm predicting 644 watt hours for the Bluetti. So how long do I think the fan will go at 885 watts? Well, it's 644 divided by 885 and times it by 60. So by my calculations, we should get about 44 minutes of the Bluetti with the same fan. Let's see if it's greater or less than 44 minutes. Now the important thing with the Bluetti is that the display does not show a percentage. We just have 5 bars here, so it's 20% increments. So with the Bluetti, you don't really know how much power you've got left. So I'm going to leave the camera running and recording the whole thing, and then we're going to work out exactly how long this lasted. It's fully charged, and we're just going to run till the power turns off. Okay, so the power, very similar to the Jackery that's been drawn here, about 885 watts, but actually it seems to be dropping already. 882, 881. One downside I've never liked on the Bluetti is that the display keeps turning off. So we can see that the output of the Bluetti is saying 862 watts. It's slightly higher than that, but what you can see is that this power is dropping as soon as we've started it. The Jackery stayed rock steady at 886, 887 for almost an hour. This doesn't bode well for the Bluetti. Right, we're just gonna run this now until the fan stops. Okay, I've got to say, I was flabbergasted by the Bluetti performance, and not in a good way. I predicted, so basically the Jackery has about 90% efficiency in terms of storage, 1002 watt hours. It basically performed equivalently like it's got 900 watt hours, about 90%. The Bluetti, if we had taken the same 90%, with 716 watt hours, running with the same fan heater, should have lasted about 45 minutes. But it didn't. It lasted only 35 minutes. So if you do the maths, 35 minutes divided by 60 in an hour, and then times by 716 gives 510 watt hours of real usable storage with the Bluetti. 510 watt hours. So 510 as a percentage of 716, which is the paper value of the capacity, is 71% efficient. So let's get to the conclusions. What do I make of this? Well, that has thrown up a real dilemma for me. Of course, we got the standard lithium-ion here, which we know is a little bit more power efficient, but this experiment shows that this is a really good technology in terms of power. 90% efficient, I think anyone would take that. You know, it's powering all the bits inside and the inverter efficiency, etc. 90%, really good. 71%, that's pretty low. This thing didn't last very long. They're about the same size, but I could run that fan heater for about an hour with this and 35 minutes with this. Yes, this is more expensive. You know, it's got that bigger headline number, 1000 watt hours versus 716. But the usable power is much higher in the Jackery. So, you know, you're basically getting nearly double the time with the fan heater or any other components compared with this. You know, in terms of price, yeah, more expensive, whatever. I like the form factor of the Bluetti. I love the fact that lithium-ion phosphate has so many more charge-discharge cycles. You know, this will last a lot longer in terms of lifetime than this. But for a very similar size package, the Jackery has twice as much power, twice as much electrical power stored inside it that you can use, really, even though the headline number is 1002 versus 716. It's basically twice as much usable energy as that. I find that really interesting. So now, you know, I'm not trying to trade off Jackery against Bluetti. They're both fabulous firms. I really like both of these power packs. But for me now, if I only had to take one with me on a camping trip, what would it be? And you know, because I've got them both, I think it would have to be the Jackery, because you're just going to get more out of it. I really am blown away by that 35 minutes. You know, and when I first reviewed the EB70, I was really interested as to why they had this battery indicator that only had 5 bars. And I've got a feeling it's because of this, the fact that it drops or you're not getting as much power maybe as you think you are. I can't think of any other reason. I may do the experiment again. This was in eco mode, which meant the display kept turning off. I'd love to see, you know, does it speed up towards the end? I've got a feeling it does. The bars, you know, it was doing really well. I thought it was going to make the 45 minutes. I went out to make a cup of tea. When I came back, it had stopped. So I don't know if it's sped up towards the end, but because there's no percentage indicator, there's no real way of knowing how much battery you've got left, and I do think that's a conscious design decision by Bluetti with the EB70. Whether this performance difference, you know, the 70% versus the 90%, whether that's due to the lithium-ion phosphate technology in the batteries, I don't know. It quite possibly is, but because Bluetti make a big point of their batteries, and they don't use standard lithium-ion. They don't have a product which uses Jackery type batteries. So I can't actually compare two Bluetti power packs with different battery technology because I don't think it exists. So what are we saying here? Well, the numbers are fairly simple. On the surface, this has got 1,002 watt hours, this has got 716. So, you know, this is about a third more on paper than this. But in reality, this has got about 900 and this has only got about 500. So it's almost, this is actually in reality almost double the storage of this in about the same size and same weight box. So I'll ask the question again, if I could only take one of these two power packs on a camping trip, which one would I take? I would take the Jackery, because you've got limited space when you're camping. This packs way more power in the same size box than this. And I love the Bluetti, I love the EB70, I think it's a great device. It's got that long lifetime, but I don't really care about the lifetime when I'm going on a camping trip and I need a power pack. I'm going to grab the one that's going to give me the most bang in terms of power for my buck, and that is the Jackery Explorer 1000. So, I hope you've enjoyed this video. Sorry if I was rambling a bit. Numbers can be a bit boring and whatever, but I think it was a useful exercise. Please like and subscribe to our Camping Secrets channel. We're going to be doing plenty more of these videos over the coming months and years. Real thanks for watching and getting to the end, and I look forward to speaking to you again soon. I've been Marky Mark, over and out.